Alright, so number 40, I need to make a correction. The answer key that I posted on School Loop is wrong. Okay, so let's start off with the drawing, the triangle. So I've got 24 as the side on the bottom, the base, and 7 is the height. Or 7 is the opposite of theta, and 24 is the adjacent to theta. So we're missing the r. So if you use Pythagorean theorem, 7 squared plus 24 squared, add them together and take the square root, you end up with 25 right here. Okay? So now, for the cosine theta over 2, since we are talking about a right triangle and it's not on an x and y coordinate, we can actually eliminate the plus minus because they're all plus, they're all positive, so we don't have to worry about that. Okay, so now I've got 1 plus cosine theta. Remember, cosine is adjacent over hypotenuse, and that's where I made the mistake. I was using sine theta by accident, divided by 2, and then it's all in the square root. So this is going to give you 1 plus 24 over 25 is actually 49 over 25 divided by 2, and it's still all in the radical. When you multiply both sides by 2 to get rid of the fraction within a fraction, top and bottom by 2, this ends up being 49 over 50, again in the radical. And so 50, you know, is 25 times 2. So the 25 comes out as a 5. 49 square root is 7, so that one's okay. And then 5, and then the 2 stays inside the radical. Now you've got to rationalize, so you got to multiply top and bottom by radical 2. And so your answer for this is 7 radical 2 divided by, now the denominator, that's 2, and then you had a 5 to begin with, so now you have a 10. So this is your first answer, the answer for cosine theta over 2. Sine theta, sine of theta over 2, it's basically the same thing. It's just with you're subtracting the cosine from the 1, so 1 minus 24 over 25. When I say the same thing, it's like the same setup, the same structure. It's just that you are subtracting in the numerator. So now this gives me 1 over 25 in the numerator divided by 2. Okay, so now I have 1 over 25 divided by 2 is 1 over 50 because I multiplied top and bottom by 2. Okay, and then we just do on the next line. 50, again, just like in the one above, is 25 times 2, so the 25 comes out as 5, so you have 1 over 5, square root of 2. I'm going to rationalize that radical in the denominator, so I end up with square root of 2 over, denominator is radical 2 times radical 2, that's 2 times 5, so you get 10. So here is your sine of theta over 2. For tangent of theta over 2, you have formulas, those you have, but you can also use the fact that tangent of theta over 2 is the same thing as sine theta over 2 over cosine theta over 2. Since you already have the values, I think it's a lot faster. So sine theta over 2 is square root of 2 over 10, and cosine of theta over 2 is 7 radical 2 over 10. So the radical 2's over 10's cancel, and you're left with 1 over 7. And that's the answer for tangent theta over 2. Alright, so for number 42, if you look at the triangle, you're missing the hypotenuse. Using a squared plus b squared equals c squared, you end up with the hypotenuse equaling 26. Because 100 plus 24 squared, you add those numbers together, then take the square root, you get 26. So notice they ask you for cosecant and they ask you for secant of theta over 2. But we don't have formulas for those. What we do have is a formula for sine and a formula for cosine. So in order to find cosecant theta over 2, I'm going to use sine of theta over 2. So again, since this is our triangle, all values are positive, so I'm not going to worry about the plus or minus. So I'm just going to write square root of 1 minus cosine theta over 2. So then square root of 1 minus cosine is adjacent over hypotenuse. So I'm going to do 24 over 26 divided by 2. So then this gives me 2 over 26. Okay, so put it right here, divided by 2. When I simplify this, I get, multiply by 2, so I get 1 over, or I guess you could think of it like this, 2 over 52, whoops, 52, but then when you reduce it, you get 1 over 26. And so you rationalize, so you end up with radical 26 over 26. And that would be, well, actually, let me take it back. Since I almost forgot, we're not looking for sine of 2 theta, of theta over 2, we're looking for the cosecant. So all I'm going to do now is take the reciprocal of this by switching these two. And so now cosecant of theta over 2 is square root of 26 over 1, which is just square root of 26. So the answer is right here. For secant of theta over 2, I'm going to do the same thing. I'm going to use its reciprocal. And we know that this is 1 plus cosine theta divided by 2, square root. Again, we don't worry about plus minus because it's a triangle. All the values are positive on the sides. All the lengths are positive. So 1 plus cosine, that would be 1 plus 24 over 26 divided by 2 in the radical, square root of all that. So now this gives me 50 over 26 divided by 2. Okay, so then that one, when I reduce it, oops, sorry, it's inside a radical. When I reduce this one, I get 25 over 26. Because I could think of it as multiplying top and bottom by 1/2 to get rid of this right here. So 50. So this equals, or I could just do the same thing I did on the one above, do it 50 over 52, which reduces to 25 over 26, take the square root, and we're going to do the reciprocal again, so I'm going to take the reciprocal of this fraction, right? Because I'm not looking for cosine, I'm actually looking for secant. So when you do that, you end up with square root of 26 in the numerator and square root of 25 in the denominator, but then that gives you 5. So that's the answer for that one.